Okay, so where we left off was on number 21. You were solving for R, because you were, no, excuse me, you were solving for Q. So it'll be R squared times E over K. So 0.2 meters squared, E was 2.8 times 10 to the 6th newtons per coulomb. And K, of course, is 9 times 10 to the 9th Newton meters squared per coulomb squared. Punch these numbers in, and you get, I think, 1.24 with the 4 repeating times 10 to the negative 5 coulombs. Okay? So, very straightforward. Just plug the numbers in. Next one gives you a Q, gives you a field, gives you a charge in a field, and it wants R. So this time E is equal to KQ over R squared. So R squared is equal to KQ over E. So 9 times 10 to the 9th Newton meters squared per coulomb squared. Q was 4.6 to the negative 5 coulombs, and E was 4 times 10 to the 6th newtons per coulomb. So 9 to the 9th times 4.6 to the negative 5, and then divided by 4 to the 6th. And that's R squared. Take the square root, and I think you get 0.3217, assuming I punch this in right. See, this is where I'm missing all of you to tell me when I screw up. 3217 meters. Okay? Number 23 is the one that wants to know how many electrons. So the first thing you do is you solve for Q. So E equals KQ over R squared. So Q is equal to R squared E over K. R was 4.6 centimeters, so 0.046 of a meter squared. E is 3.95 times 10 to the 3rd newtons per coulomb. And then you're dividing by 9 times 10 to the 9th Newton meter squared per coulomb squared. So 0.046 times 3.95 to the 3rd divided by 9 to the 9th, and that's Q. So Q ends up being 2.018 repeating. 2.01 with the 8 repeating times 10 to the negative 8 coulombs. But the question wants to know, how many elementary charges would this be? So to figure that out, you're going to take your total Q, which you just found, and divide it by the charge on one electron or one proton. So this 2.018 repeating times 10 to the negative 8 newtons per coulomb, and that gets divided by 1.602 to the negative 19 coulombs. So divide by 1.602 to the negative 19, and you get 2.16 to the positive 11. So our number of elementary charge is 1.26023 times 10 to the positive 11 e's. Okay? Alright, the last question that I asked you to do over the weekend was number 29. Okay? And it was adding up fields. And I started you out easy because they're in a straight line. So you have two charges. One have negative 40 microcoulombs, so negative 40 microcoulombs, and the other positive 50 microcoulombs. And the question tells us that they are 12 centimeters apart. and it wants to know what's the electric field intensity at the midpoint. So right here. So you need to find the field from number 1 and the field from number 2. And you can do this. So E1 is equal to KQ1 over R1 squared, and E2 is equal to KQ2 over R2 squared. So 9 times 10 to the 9th Newton meters squared per coulomb squared. Q1 is negative 40 times 10 to the negative 6. And R1 is 6 centimeters, so 0.06 meters squared. And this one, 9 times 10 to the 9th Newton meters squared per coulomb squared. This guy is positive 50 times 10 to the negative 6. And it is also 0.06 meters squared. Okay, so now do the math. 9 to the 9th is 36 divided by 36. The top one's going to be 1, I think, times 10 to the something. I have to punch it in because I don't know what the something is. So what was it? 40 to the negative 6. And then divided by 0.06 squared. So 1 to the 8th, I think. So 1 times 10 to the 8th newtons per coulomb. And then this one's 5, so that's 45 over 36, which is like 1.25 maybe? E to the 9 times 50 to the negative 6 divided by 0.06 squared. 1.25 to the 8th. Newtons per coulomb. This one, though, is a negative. Okay, so now it wants the total field. Well, the negative here just means the field is going into the charge, and the positive here means the field is going out of the charge. So if we look up here, the negative from the number 1 means at this point the field's going this way. The positive from number 2, so this one means into source. And this one means away from source. Now, the source in this one is number 1, and the source in this one is number 2. So the charge acting at this, or the field acting at this point from charge 1 is going into charge 1. The field acting at this point from charge 2 is going away from charge 2. What do we do to get the net field here? Well, look at their directions. They're going the same way. So the total field, it will just be equal to 1 times 10 to the 8th plus 1.25 times 10 to the 8th newtons per coulomb. Notice that I dropped the negative because the negative was just telling us our direction. And so once I looked after my direction, the negative goes, they're both pointing the same way. So to get the resultant, we add them together. So the total E, the total field at the midpoint will be 2.25 times 10 to the 8th newtons per coulomb. And in brackets you would say towards the 40 microcoulomb charge. Okay? Or you could put away from, okay, and away from the 50 if you want. So it has to be going, and the way I have it drawn, it's going to the left. Okay, so now tonight I asked you to try number 26. And it's similar in the sense that first you're going to find the field at point C from A and from B. It's just this time they're not going to be in a straight line because that would be too easy. So here's C up here, here's A, here's B, and it wants you to find the net field at C. So you're going to need this line. This is 4 centimeters. This is